Okay, now that we have a good understanding of some of the benefits of a modern unified data and analytics SaaS platform, let's look at an example of one of these platforms, which is Microsoft Fabric. So what is Microsoft Fabric? Well, Microsoft defines Microsoft Fabric as an end-to-end cloud-based analytics platform that unifies data movement, processing, storage, and visualization in a single SaaS solution. All workloads run on top of OneLake, a unified open data lake storage layer supporting Delta Lake format. It's important to remember that each Azure tenant gets one instance of a OneLake, and OneLake is basically an ADLS Gen 2 abstracted under the hood. For the compute engine, Microsoft Fabric powers data analytics, data science, and real-time workloads. It includes Apache Spark for data engineering, a distributed SQL engine for warehousing, and real-time intelligence tools like event streams and real-time hub for low latency data ingestion and streaming analytics. It also has a unified scheduler which allocates compute across services, enabling efficient processing over OneLake with open formats like Delta Lake and Parquet. So let's go over some of these components. Data Factory, very similar to Azure's Data Factory, orchestrates and automates data integration pipelines, enabling seamless ELT workflows across diverse data sources within Fabric. From a data engineering perspective, the platform provides access to Spark compute engines, along with native Spark execution engines for big data processing, data engineering, and machine learning workloads. You will have access to notebooks, pipelines, and large-scale data transformations with extremely high efficiency. It also brings a Lakehouse engine, which combines the flexibility of data lakes with the management and performance of data warehouses. The data is typically stored in Delta Lake format for analytics and machine learning, enabling both SQL and Spark-based processing. For data science, you'll have notebooks and fully managed Apache Spark environments for scalable data exploration, preparation, and machine learning, supporting Python, Scala, R, with advanced features like native execution engines for accelerated analytics and seamless integration with OneLake. From a data warehousing perspective, you'll have access to scalable, high-performance SQL analytics over structured data. This can support enterprise data warehousing scenarios with features like T-SQL support and advanced security. From a real-time intelligence perspective, you'll be able to handle real-time data ingestion and processing from sources like IoT devices, applications, and logs. Support for streaming analytics and event-driven architectures for instant insights. You'll also have Eventhouse, which is optimized for high-volume, real-time event data storage and analytics, which enables fast querying and aggregations of streaming event data for operational intelligence. From a reporting perspective, you'll be able to integrate all of these components seamlessly into Power BI to deliver interactive data visualizations and BI capabilities. You'll be able to enable users to build and share dashboards and reports directly on top of OneLake data with Direct Lake and also PBIP for version control and integration with deployment pipelines. From a monitoring perspective and alerting, you'll have Data Activator, which is a no-code automation engine for data observability and triggering actions based on data changes or anomalies. Mirroring is another neat capability which offers near real-time replication for seamless replication of operational data from databases and warehouses into OneLake for your analytics. It brings low latency, low cost and really eliminates the need for complex ETL, providing a turnkey, fully managed solution for continuous data integration. The platform is secure and flexible to support sources behind firewalls and offers granular control on what's mirrored. It's analytics ready, so mirrored data is stored as Delta tables, instantly available for Spark, SQL, and Power BI workloads. You'll also have access to shortcuts, which are virtual data access pointers to external data sources like Azure Data Lake Storage or Databricks, Unity catalogs, so on and so forth, so it appears in one lake without duplicating or moving files. This brings real-time updates, so changes in source systems are immediately reflected in Fabric, ensuring users always work with the latest data at all times. So it's truly unified analytics, enabling seamless querying and analysis across multiple data sources as if all the data resides in one lake. When it comes to managing Microsoft Fabric, it's essential to understand the different levels of administration that keep the platform secure, efficient, and collaborative. Let's walk through the hierarchy together, highlighting how each layer plays a distinct role, right down to the finest details. At the very top, we have the tenant level administration. This is the governance layer that spans the entire organization. Here, roles like the global administrator and Fabric administrator have broad oversight. They set the policies that affect every domain and workspace, manage user access and security, and ensure compliance is never an afterthought. Think of this as laying the foundation for how your entire organization interacts with Fabric. Moving down, we reach capacity level administration. Capacities are dedicated pools of resources, compute and storage, from which different business units or workloads can draw. The capacity admin's job is to allocate these resources, assign workspaces appropriately to capacities, and fine-tune performance, making sure that each business line operates smoothly and efficiently without stepping on each other's toes. Next is domain-level administration, which is especially relevant in organizations embracing a data mesh approach. Domains group related workspaces, often by business unit like finance or marketing. Domain admins and contributors tailor governance, adjust metadata, and assign workspaces ownership, all within the scope of their domain. This empowers business units with autonomy to manage their own data while still operating inside the organization-wide guardrails. Drilling further down, we come to the workspace level administration. Here, workspaces act as containers for key data assets, datasets, reports, dashboards, you name it. Workspace admins and their teams make sure that each area of work has the right access, assigning roles and managing permissions, that collaboration happens securely and efficiently. This is where project teams get the control they need to build, analyze, and share insights. But administration in Fabric doesn't just stop at the workspace. For more granular control, we have object and file level administration. This lets organizations specify access to individual reports, tables, or files, providing targeted protection and flexibility for sensitive assets. And finally, at the deepest level, we come to row and column level administration. This is where security policies can be applied directly to the data itself, limiting what information different users can see right down to specific columns or rows in a table. When these levels work together, organizations get a framework that is both robust and adaptable. You maintain enterprise-level governance while also empowering domains and teams right down to safeguarding every data point. This layered approach is at the heart of secure, scalable, and innovative work in Microsoft Fabric. I want to introduce you to how Microsoft Fabric implements the data mesh paradigm to empower domain-oriented, self-service data ownership while ensuring enterprise-grade governance and scalability. At its core, a data mesh decentralizes data ownership and treats data as a product owned by domain teams. Microsoft Fabric enables this by organizing resources into domains and workspaces within a unified SaaS environment. Let's break down the architecture and how this approach works in practice. The platform runs within an Azure tenant configured with secondary region failover for high availability and disaster recovery. It leverages two Fabric capacities, an F5064 for development and an F128 for production, with paired region replication to ensure business continuity. Storage is maintained through a single tenant Level 1 lake, providing zone and locally redundant storage for durability and readability. Now here's where the modern automation and governance shine. When users need a new workspace or domain environment, the process starts with a service request, typically submitted through commonly used IT service platforms like Jira or ServiceNow. This request then moves through an approval workflow, ensuring proper oversight and compliance with organizational policies. Once approved, the system triggers an automated DevOps pipeline built into Microsoft Fabric and integrated within Azure DevOps, which then creates the requested workspace or domain environment in the Fabric capacity, complete with the appropriate permissions and configurations at both the workspace and domain levels. This automation can also be managed manually if needed, but the goal is really to enable fast, governed, self-service provisioning. From the data mesh paradigm perspective, this empowers teams to have product-based ownership at the domain and workspace level, the finest granularity where real business value is generated. Within these domains, data scientists and machine learning teams build and manage their ML models. Data engineers maintain data ingestion, transformation pipelines, and enterprise data warehouse modeled with dimensional star schemas. Business analytics teams work within their own workspaces, often aligned to domains such as revenue or marketing, to create semantic models, Power BI reports, and data sets, utilizing source control and continuous integration and continuous deployment pipelines. This approach balances business domain expert empowerment with technical oversight and agility using DevOps best practices. The domain teams typically include analysts, analytics engineers, and Power BI developer roles that apply software engineering principles to ensure quality, repeatability, and governance. Finally, once the artifacts are approved through these pipelines, they're deployed to production environments accessible to business users, ensuring enterprise security, compliance, and governance are maintained throughout. This combination of ticket-based environment request workflows, approvals, automated DevOps provisioning, and domain-level ownership exemplifies how Microsoft Fabric's data mesh implementation delivers scalability, agility, and strong governance simultaneously. Let's walk through the critical phases of a successful migration plan, covering everything from leadership buy-in to change management that drives a smooth and well-governed transition to Microsoft Fabric or any modern unified data platform. Number 1, executive sponsor buy-in. This is the first crucial step. Securing leadership approval means not only getting the budget, but also gaining committed sponsors and setting the governance groundwork. We present a compelling business case with clear ROI and project goals to ensure alignment at the highest level. The outcome is an approved project charter, clear sponsor roles, and a structured communication plan to keep all stakeholders engaged. Number 2, enterprise architecture assessment. Before diving into implementation, we need to thoroughly understand the current landscape. This means analyzing existing systems, data flows, and technologies to identify gaps and risks. Mapping dependencies helps us select the right enterprise architecture framework that fits organizational needs. Deliverables here include detailed architecture documents, a gap and risk report, and a strategic migration plan. Number 3, planning the proof of concept. Next, we define the POC scope, choosing target workloads and setting success criteria. A cross-functional team is assembled and technical architecture is detailed. This phase is about laying a clear, actionable plan for the POC and ensuring stakeholders are aligned. Key deliverables are the scoped project plan, success metrics, and a communication strategy for engagement. Number 4, implementing the POC. With planning complete, the POC environment is built on Fabric. Selected data and workloads are migrated, and integration, performance, and governance tests are conducted. Feedback from users helps us analyze outcomes and refine the approach. Deliverables include an operational POC environment, comprehensive test reports, and documented lessons learned. Number 5, scaling the platform through phased migration plans. Based on the POC insights, a phased migration roadmap is created. We prioritize domains by business value and technical complexity, form migration teams, and plan resource allocation, timelines, and governance updates carefully. Deliverables include the complete migration roadmap, resource planning documents, detailed workflows, and updated governance policies to support scale and control. Number 6, eliminating technical debt from underperforming systems. Parallel to scaling, we systematically identify legacy systems, redundant code, and manual processes that slow progress. Plans are made to decommission or refactor these components while maintaining data quality and security during transitions. Deliverables include a technical debt inventory, refactoring and decommissioning plans, and updated system documentation. Number 7, testing. Rigorous testing ensures reliability. Unit tests, integration tests, system validation, and user acceptance testing confirm that data integrity, performance, and compliance standards are met. Detected defects are resolved and formal sign-offs obtained before moving forward. Deliverables include detailed test plans and scripts, execution reports, default logs, and final UAT sign-offs. Number 8, training. Effective adoption depends on empowering users and admins. Role-based training programs are developed and delivered, including documentation, hands-on sessions, and ongoing support channels. Feedback is gathered to refine training and plan continuous education. Deliverables encompass training materials, session attendance records, and feedback reports. And finally, number 9, change management. Finally, we drive organizational adoption by communicating the migration benefits, timelines, and impacts regularly. Change champions are engaged to help manage resistance, and feedback loops keep adjustments responsive. Continuous support and adoption tracking ensure the platform's successful use over time. Deliverables include the change management strategy, engagement documentation, adoption metrics, and ongoing feedback reports.